it was 4 years ago when we had all sorts of propagation. So maximum usable frequency is right near 40 meters. Last I heard, it was sometimes 40 meters worked, sometimes 40 meters didn't, so it depends. And 80 meters is not really good for daytime because of the noise, but it's not real good propagation right now. But if you pay attention to what the sun's doing, you can get through. Whoa. Ground wave is important for low frequency and medium frequency, like I said, AM radio. It tends to follow the Earth's curvature because the refractive index is such that it keeps it right close to the ground and curving with the Earth's curvature. Sky wave is where we get into the ionospheric bounce, or we get to tropospheric index of refraction differences, then we have troposcatter, tropoducting, or we go up into E layers. We'll get to those in a second. Here, D layer was first discovered, but it's the problematic. It's daytime and it's absorptive. So when the D layer is really strong, it cuts down on your propagation immensely. You have to get through the D layer. But it's also frequency specific. So if your frequency is high enough, you'll cut right through the D layer. Or if you aim high enough, you can cut through less of the D layer and get less absorption. The E layer now is the first one that really helps us bounce. It's very low. It's about 40 miles up or so. And so you can figure out how many hops you've taken by using the E layer and just starting to look at triangles. You can actually hear how many hops you've gone through too. Something might work at 20 degrees, but it won't work here at 45 degrees.
And people say, oh yeah, you must have worked on E-skip. I'm like, I thought it was all skip. Like, you know, I mean, if you're working DX with somebody in the middle of the day on 20 meters, isn't it got to be D or E?
No, D is absorptive. E is the one that might work. F is probably the one you were using.
Okay.
Where was the DX? That will tell you.
Well, for instance, in the early AM on 20 meters, I get Europe.
Okay.
In the early afternoons and evenings on until about dark, I get Japan, Asia, and deep South America.
Okay,
So
you probably
what am I working with those guys? Because I was just going over the poles to get to Russia, or even over the poles to get to Europe. A straight line from here to South Africa is over Greenland.
One time, all of a sudden, the middle of the Saratov, Russia, came in really, really strong. Nice CW fist. Those guys are really good. They need 30 words a minute to get their license. So they're real good. I was working him, and I figured out we're working all the way around the world, dark to dark, because the sun had just gone down. I had lost 20 meters on the daylight side. I worked him 20 meters. He was in the dark, and so was I. So I worked long path. It was really, because I wasn't hearing auroral. I know I wasn't going over the pole. That's really easy, and you know when you're going over the pole.
So how would I know which one I mean, can I look through my logs and go, yeah, that was probably over this, or that was over that, or?
It depends. Are both in daylight? Are both in dark? Then you can normally tell direction.
Well, yesterday's, for instance, was Belgium at about noon, and he was 2-3 hours in the dark on 20 meters. And I was on 20 meters at noon here.
That one's strange. You probably did work him straight and not around, because Belgium's really pretty close.
Yeah,
Saratov is almost on
under
the
6
other side of the world. So it really does depend, and it helps if you can hear what's going on. So you look at how far it is, you look at the various directions you can get to him. I mean, because you can go over both poles. I have worked long path over the South Pole.
Okay.
Because I knew it was Aurora, but we couldn't figure out how in the world I got over the North Pole. We figured you went the other way. I have a V, which doesn't go anywhere. It doesn't move.
So is it just particularly the time of day that you can count on that? Like if they're in the dark and you're in the dark, and you're on the same band?
I would say you're going along the dark all the way around.
See, I always thought it would be you'd be going the shortest, well, the shortest distance would be like between you, wouldn't it?
The
Well, depends
shortest,
which way you're going, I guess.
the
huh?
shortest path is not necessarily the strongest path,
Okay.
because the deabsorption is really, really strong, and it would kill straight line through the sun, especially during summer, during our high summer and Europe's high summer. It would be very, very strong during the daytime. But if you work them all the way around the other side of the world, D layer is dead. D layer dies rapidly after the sunset.
Okay.
E layer takes a little bit longer, but it's also high enough so it's still getting sun. F layer takes longest. Where did I show you that picture? This one. This takes the longest to die because it's highest. It's let's see, it's almost 200 miles high. When you use the F layer, you're bound. One hop will get you, let's see, from here to Chicago on 20 meters approximately, or here to Ohio, someplace in there. 2 hops means you're in the Atlantic. Another hop means you're in Europe. If you're a little bit lower and you're using the F1 layer, which is, see, the F region covers all of this, and it moves daylight and nighttime. In the daylight, it splits into 2 layers. In nighttime, it's only 1 layer, but it's actually a little bit higher and it's a little bit weaker. So you can bounce incredible. When I use 40 meters here, I normally get, Texas is very weak, Colorado is very strong, Arizona is very strong, BC, mid to northern BC is very, very strong. By the time I get into Washington, I'm starting to have problems.
So you can also tell if based upon where all the signals are coming in the strongest. Like Arizona kills me. I hate Arizona, I hate Colorado, I hate Alaska. Those 3 places are all right between around 1,000 miles. The places I hate to see come on because they just watch my waterfall. Those are always the strongest states.
For me, they're really weak. But then again,
But that's on 20 meters.
Oh,
And
for,
yeah.
okay. At 20 meters daytime, 20 meters night.
20 meters daytime, they kill me.
I only work HF in the morning and at night.
I don't want to keep you too long, but I'd really like to get a better grip on the, how to tell which way I'm going.
Well, the best thing
What I'm
is to
using.
keep listening and get call signs and look them up.
Well, I can look them up every time I get a call sign.
No, look at everybody around them, not just the guy you're working, but get as many call signs as you can.
Okay.
Okay. So these are the various layers. F is day and night skip, we covered that. D is 40 to 60 miles high. It definitely attenuates RF, so you know that if it's, especially in the summer, in the winter it's not as strong because we're not getting the direct insulation like we are in summer. But you can tell that from here to New York, on the daytime, it's not really possible. If it happens, it's very, very lucky. E layer is something that we don't really use except certain frequencies. Tropoducting is in the E layer. Sporadic E's is the E layer. The F layer is what is basically HF. So this is not something that's really applicable to what we're doing. But for HF, we use F layers all the time. Here's another way of looking at it day to night. And this is basically a density. So there's not really layers, so to speak. There's regions. And it's depending upon the density of the ionosphere, and it's going to be densest the closest it is to the sun, and least dense further away, because you're actually absorbing UV particles as they come in. I didn't put up the chart for the different frequencies that are being absorbed from the sun, because there are various frequencies at various layers. So if the sun is more active at a certain frequency, it will be reacting with the D layer, the E layer, and the F layer.
So, why is the sky blue?
Oh, that one's easy.
When the F layer splits, is there something between F1 and F2?
No, it's density. So what you have is 2 areas that are higher density, all within the F
So they
region.
kind of overlap or something. All right.
Yeah, well, They are split